In this lesson, we're going to be looking at how to divide fraction word problems. A word problem is a fraction word problem or a division word problem if you have a quantity of something and you're making groups out of it. I think I should actually put division here. Now there are several steps. I'm not going to read each step to you, but we will refer to these as we go through them. So I will read our first problem. A baker has 5 1/4 pies in her shop. She cut the pies in pieces that are each 1/8 of a whole pie. How many pieces of pie does she have? So first I need to identify what the person is starting out with in the real world. So I'm going to circle this and label this 1 for step 1. And then what are the equal groups that they're making? 1/8 of a whole pie. I'll label that with 2. The starting quantity goes first in the division number sentence. So we have 5 1/4 followed by, or divided by, 1/8. Now to help me really visualize this, as it says here, imagine what's going on in the real world, I need to help myself imagine what this looks like. And how I do that is I draw pictures. So it says pies, so I'm going to draw 5 pies, and we have a 1/4 pie. So I could make this a circle as well, and then just color this out so that I know that I have 1/4. Now I know that if I cut a pie into 8 pieces, it will look like this. So that would give me 1, 2, 3, 4, 5, 6, 7, 8 pieces. Those are 8s. And if I do that for each pie, we'd have 8, and 8 plus 8 is 16, plus 8 is 24, plus 8 is 32, plus 8 is 40. Now when I get to this one, this is 1/8 of a pie right here, even though I don't have a whole pie. So that's 2 8s, so that gives me 42 pieces altogether. Now I can check that with what I'm doing here. For me, it's easier if I change this mixed number to an improper fraction. So I know I multiply the denominator by the whole number and then add it to the numerator. This is how many pieces. So I'd have 4 pieces for 5 wholes, that's 20. 4 times 5 is 20. And add that to 1 gives me 21/4. And that's what I start out with. When all of these, if they were counted as fourths, this would give me 20/4, and then I'd have one more fourth right there, giving me 21/4. And now, I'm actually just going to write this again. Then I'm going to do KFC. KFC means I keep the first one, so that's 21/4. I flip the second fraction, so that's 8 whole numbers, or 8 wholes, or 8 over 1, and then I change the operation. So instead of division, I'm now going to multiply. And I can cross cancel because I know that 4 and 8 have a common factor. The factor is 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. So that will give me 1 times 1, and 21 times 2 is 42. So just like I found out with my picture, I have 42 pieces of pie. 42 eighths, more specifically. So how many pieces does she have? She has 42 pieces of pie. Let's go into another problem. I feel like this first one is an especially easy one to visualize, whereas these later problems aren't as easy to visualize in this way. Here it says a turtle can walk 1/12 of a mile in an hour. The turtle is 5/6 of a mile away from a pond. At this speed, how long will it take the turtle to reach the pond? So in this case, I'm not starting out with objects, but I am starting out with the distance. So I'm going to label that here. So we have 5/6 of a mile. That's my first number. And then I'm dividing that into 12ths. So that doesn't mean I'm making 12 pieces right here, but that means the pieces that I have are going to be the size of a 12th. So a 12th of a mile, that would be my second number. So I can set it up here, so I have 5/6 divided by 1/12. The starting quantity, which in this case is how much distance we have, is 5/6. And then I'm dividing that into 1/12 sized pieces. Now, again, I'm going to draw a quick picture. It says that the turtle, and I'll draw my little turtle here. It's kind of a weird looking turtle, not as good as the one I did before. Our little turtle is 5/6 of a mile away from the pond. Here's my little pond with the fish. Okay, now this is 5/6, so I'm going to go ahead and write that out. So we have 1, 2, 3, 4, and actually I did this a little bit wrong. I'm going to make this a little bit shorter so these pieces are equal. That's 1/6, 2/6, 3/6, 4/6, and 5/6. I switched the line being a slash to just a horizontal line because it fit better. So 5/6 of a mile. The whole distance is not the distance from the turtle to the pond. The whole distance is a mile, and this is telling us that our distance to the pond is 5/6 of a mile. Now here, it's 1/12 of a mile in an hour is what we're dividing this by. And I know that 1/6, I'm going to do it this way. 1/6 is equal to 2/12. So this would be 1/12, this would be 2/12, and so on. I'm not going to write all of them because that would be more than I have space to do. So I know that each part of this mile takes the turtle 1 hour. So there's 1 hour, 2 hours, 3 hours, 4 hours, 5, 6, 7, 8, 9, 10 hours. This right here would be 10/12. If you left yourself space, you could write in all of those different fractions there. Now I've drawn this model to help me visualize what is going on in this problem. Now I'm going to follow the steps for KFC. I have 5/6 divided by 1/12. I keep the first fraction. That gives me 5/6. I flip the second fraction. That gives me 12 over 1. And then I change the operation. So instead of dividing, I'm now multiplying. Now I can cross cancel because 6 goes into 6 one time and 6 goes into 12 two times. So 5 times 2 gives me 10. 1 times 1 gives me 1. Just like I figured out here, 10 miles, or 10 hours is how long it will take the turtle. So it will take the turtle 10 hours. I'll go ahead and put this in a box. Now our next problem, I'm not going to write a diagram for you. You can try to do this on your own. It's very similar to our last problem. Erica can run 1/6 of a mile in a minute. Her school is 2/3 of a mile away from her home. At this speed, how long would it take Erica to run home from school? I will note on a line here, if I had cut this into thirds, this is 1/3, 2/3, 3/3. If I cut these pieces in half, very similar to what we saw with our 12ths, this gives me 6. Okay, so if I cut thirds into half, I get 6ths. So it's telling me that she can run 1/6 of a mile, that's this, in a minute. Her school is 2/3 of a mile away. So right here we've got 2/3 miles. Here we have our 6ths. It takes her 1, 2, 3, 4 minutes. So let's see if that works out here. So again, I'm going to mark here, my starting amount is the 2/3 of a mile. That's how far away she needs to go. This is what we're dividing that distance into, 1/6 of a mile. That's 2. So we have 2/3 divided by 1/6. I'm going to keep the first fraction, so that is 2/3. I'm going to flip the second fraction, so that's 6/1, and change the operation. So we now multiply. Again, I can cross cancel because 3 goes into 3 once, and 3 goes into 6 twice. And that equals 4/1. So just like I had drawn here, it took her 4 minutes to run those 2/3 miles. This final problem is one that you can try at home on your own.